Welcome back to the channel. If you're new here, my name is Rick, and normally I make videos on heating, air conditioning, and refrigeration, and I also do home standby generators. And today we're going to be doing a review on the OPS Mega 2. The OPS Mega 2 is a brand new series out from OPS that offers 2,500 watts of pure sine wave power with a 2,048 watt-hour battery. The OPS brand has been known for making reliable units at an affordable price without all the bells and whistles. Now with the release of the Mega series, they've offered a few of those features that they didn't in the past. Now one of the big features is the ability to add expansion batteries to the unit. This one allows you to add up to 4 additional batteries, taking your power from 2,048 watt hours up to 10,240 watt hours. And if the Mega 2 series is not large enough for your needs, they also make the Mega 3 and Mega 5 series, which have even more capacity. Another very useful feature is the UPS battery backup system. You can now plug this straight into the wall and power your device, and when the power would go out, it'll automatically switch over in as little as 20 microseconds. This is going to allow you to have battery backup for your computer, multiple different items, whether it be a lift chair, CPAP machine, whatever the case is, you're going to be able to power those with uninterruptible power. Now, in order to charge the lithium ion phosphate battery that has 3,500 life cycles to 80%, you're able to charge that with an AC wall outlet at up to 1,600 watts of power, and you can do it from solar at up to 2,100 watts of power, which you can combine both of these together to give you up to 3,700 watts of power to charge at one time, which can knock your charging time down to as little as 36 minutes. Now, I do mention that it does have the lithium phosphate battery because it's a safer battery and a longer lasting battery than lithium ion. And OPS is able to offer all these things plus a 3-year warranty for a power station of this size in the 2,500 watt range, all for the lowest price on the market. Right now, they are able to beat out the Blue Eddy, EcoFlow, and the Jackery. Now, before you think that I'm a statue stuck behind here in a monotone voice, let's get started with some invasive testing, making sure that it provides the power that it's rated for, that the actual battery is lasting as long as they say it will, that the charge rates happen where they happen at, that the sine wave's pure just like you see it down below, what voltage does it actually operate, how does it operate under load, and is it worth buying? And right now through December 2023, OPS is running some of the biggest sales of the season. And with my discount HVACR, you can save even more money. I'll have links down in the description below, so be sure to check those out. All right, so what I like about the layout here is it's very clean and it's simplified. The display is very easy to read. It doesn't have any fancy jargon on it. It's watts in, watts out. What's your hours left? You have your rotary dial here that basically tells you whether it's going in or going out, and then the percentage that's actually there. Down below confirms whether you've got the output for the USBs on, or the AC, or the DC over here, and it's just simple layout. On the top left-hand side here, we have a 30 amp, 12 volt Anderson output plug. Below that, we have 2 USB-C PD 100 watt quick charge, and directly below that then we have 4 USB-A quick charge 3.0s, and you have the power switch down here below. Over here on the right-hand side, we have the 12 volt car charger plug, has a rubber boot right over top of it to keep the muck and stuff out. And below that, we have 2 of the DC 5521 plugs, which both of these are actually rated at 10 amps. Then below there, they have the power switch to turn it on and off. Then down here on the bottom, we start off with a total of 4 20 amp, 120 volt outlets. Then off to the right, we have 120 volt, 30 amp RV plug, which it's a 30 amp plug, but it's only still rated at 2,500 watts. So don't let that confuse you that you think you can actually pull 30 amps out of it because the device is not rated for that. Now over here to the left-hand side, we have 2 high-speed fans, which these are a little bit noisy, but I would rather have my appliance running cool than I would have it running hot and quiet. Heat is what destroys batteries, and that's what destroys electronics. So that's one of the only negatives I've seen so far, is that it's a little bit noisy. Down below here is where your extra batteries plug into it, which you've got a plug right there. Now this is a 48 volt system. So these batteries are tested in right now at 56.52 volts, which in theory is a 48 volt system. That is on both of these 2 different prongs here. This is, I believe, a proprietary plug, so they do not recommend you use other people's batteries. However, they do give you a lot of plug adapters so that you can use other people's solar panels. Another nice surprise was that they included quite a few extra cables to make your setup a little easier. We have an Anderson to MC4, that's a 14 gauge cable in the middle. We have an Anderson to Anderson, which has got a 12 gauge conductor in the center of it. We have an Anderson to 7909, and that is also a 14 gauge conductor in the middle. And finally, we have a 12 volt to Anderson charging port. This is so that you can charge it off the car while you're driving. This is rated for 10 amps. It has a 14 gauge conductor in the inside, and it has a 15 amp fuse, glass fuse there in the end of it. That obviously is going to charge, if you do the basic math here, 10 amps times 12 volts or 13 volts, you're only going to come in at around 100 to 120 watt charging speed. And with 2,048 watt hours, it's going to take you a little while to charge up. But if you're traveling, you know, it's free power. And on the other side, we have another set of fans, which, like I said, they're big into their cooling, which is going to make the equipment run longer. You got 2 fans going in here and 2 fans on the back side, dragging the air across. On the inside here, we have an Anderson plug adapter that's rated for 12 volts to 150 volts. This is where you're going to plug in your solar or your car charger. The total maximum input is 15 amps on that. Directly below that is our 100 to 120 volt plug. It's rated at 16 amps. And finally, we have our 120 volt plug here. This is a 14 gauge cable. It does have a little bit different plug on the end, as you can see there, that's 2 flat ones. Generally, what you're going to see is more along the lines of this one on my left. There's also quite a size difference there between the 2 of them. Just something worth noting. And up here on top, we have 2 big old go handles that you can grab a hold of for easy carrying. So this is rated at 48.5 pounds, so it is manageable to be carried around. And for those out there that don't have a lot of room, this is 18.1 inches wide, 12 inches tall, and 10.6 inches deep. Okay, we just did the full load test on it. We ran it at about 900 watts continuous until the system completely depleted down to 0%. The meter came in at 1.85 kilowatt hours, and that comes in at about 91% efficient. That's really good. All right, so we went ahead and did it a second time here. Wanted to see if it was accurate. Even with the battery dead, we're at 118 volts. Let's go down. 1.9 kilowatt hours. So that comes in right at 92.8% efficient. That's pretty good. That's the best I've had so far. And it ran that 900 watt load for about 2 hours and 10 minutes. All right, so we just begun the charging process. We went completely from 0. Currently are charging right around the 15 to 1600 mark that you've seen right there at the bottom right corner. We're gonna do a audio test here to see how noisy it is. We are right at about a foot distance away from it. Let's do it in the silence and see what we got. Now the fans are very noticeable. Now let's go ahead and stop the unit. We'll see what the normal ambient is without it running at all. So the noise floor in the room right now is right around 40 to 41 dB. All right, so right now we've got an electric heater on there. We've got our oscilloscope running to show our sine wave. We've got our multimeter over here telling us what our actual output voltage is. We have an inductive load down there, which we can watch that here. You can see we're pulling 5.1 amps on the blower motor with a power factor of 0.81. Power factor is how your amperage and your voltage is on the sine wave. Most of these tests with resistive tests is a perfect 1 power factor. When you get capacitive tests involved in it, things start getting a little wonky and they get a little different. But we're gonna go ahead and just kind of run that all together now and see where we can max out at. Right now, as you can see on the display here, we're running right in at 1800 watts. Heater's on high, blower's running. Now we're gonna add one more resistive load here, which takes us right to 2500 watts. It's dropping a touch. We are holding right in at 119 volts. Sine wave over here is perfectly stable to a point. We have a little bit of funkiness going on in the middle, but you can see we're holding in there fine at 2500. We do have a little bit of room to work with, but anything over 2500, you're gonna max out, and right there you go, she flatlined and shut down. Going back over to our code, E01, output overload protected. Now to reset that, you just hit your AC, remove the load problem, turn it back on. It takes a second, boom, instantly comes back up, 119 volts. You can see when you're really hammering down on it how fast you can drain that battery down. A lot of times I think people don't really understand exactly what's going on here. This is not a gas generator where if you just keep putting fuel into it, it just keeps running. This has so much fuel and it's rated in watt hours. As you take those watts out of there, that depletes your battery and you have to recharge it, obviously. If you have a solar panel, that's going to help bring that back in. But as you can see, for the most part, we are pretty clean on our sine wave here. Which looks really good. We're holding in perfectly at 60 hertz, which we can see down at the bottom. You can also see it over here, running perfectly at 60 hertz. That's important for your electronics. Now this has a 5400 watt surge capacity, but what that means is up, back down, nice and quick, up, back down. It's not going to sustain it for a long duration of time. We're talking seconds or less. Now something I'm going to note, which I just found out, so let's look at that sine wave. You got a little wonkiness going on in here. What that is basically noise. When we unplug the blower, it instantly goes away. So we have noise on the line. That's why I wanted to do an inductive load versus a resistive load. A resistive load is what your electric heaters are. It's a constant amperage and voltage. As soon as it comes on, boom, instantly stays there. To give you a quick example how that is, we turn on the heater, instantly goes right to 11.3, 12 amps. You can see on a resistive load, your power factor is 1. That means the voltage and the current is perfectly in sync with one another on that AC sine wave. But when you get the sine wave out of whack, and you can see right there, the sine wave's holding pretty darn steady there. That's also with the motor running. As soon as we pull that motor off, instantly cleans up. So what you're seeing there is the waveform disturbance because of the motor. All right, now we're going to go ahead and get into the testing of the 12-volt section. We've got the Anderson plug that you can charge it with actually plugged into the 12-volt car plug here. We're bringing that down here. You should never coil your wires up like this, but for demonstration purposes, I'm keeping it short so that you can see that we're actually testing it right off the outlet. We're using this because it's actually heavier rated, so we're bringing it down to the Anderson plug, to the gators, down to the actual DC tester. What this test is going to tell us is, does it actually produce 10 amps of current? And what does it actually trip out at? As we can see down here, we're right at 12.7 volts. We're going to go ahead and start out with our current. We're going to go ahead and take this right up to 10 amps. Right now we're pulling right at the 10 amp mark. Our amperage, like I said, is also down here digitally, and the voltage that we're at is right here. So we're right at 12 volts. All right, now we're going to go ahead and do by tenths, and we're going to see where we actually trip out at. You can see our voltage here on the left-hand side is holding in there steady right now. So 11.1 amps is where it shuts down at. This thing's designed to last a long time. It's got protection pretty much for about everything under the sun. I counted up a total of about 27 different codes that it can give you for potential protections. So what we have right here is the E10. E10 comes as cigarette lighter port, overloaded or shorted circuit. So it tells you exactly what's going on there. It tells you how to reset it, which what you have to do is hit your button here, turn it off, turn it back on, and you're good to go again. Now we're going to go ahead and test out that 5521 plug. We're going to use the adapter, plug it right into the unit. Now the cable that comes with it isn't the heaviest gauge in the world. As you can tell, we're at 11.3 volts, so we do have some voltage drop. You can feel a little bit of warmth in the wire after some time. I mean, it's not to the point where it's going to melt it down or anything like that, but you can tell that it's maxing out at its total capacity. We'll go ahead and take this up one by one and see where it trips out at. Now when you look up here to the top, we are pulling 141 watts, but you can also see that right down here at the bottom, which that tells us that the meter on the device is accurate. We're at 10.2, 3, 4, 5, 6, 7, 8, 9, 11.1, shut down at the same amperage. Now the way I like to test my PD ports is by actually using a device that will charge at the wattage that it's going to charge at. So what we've got here is we have the USB-C going through the meter, going right into the quick charge port. As you can tell, it picked up the protocol that it's running at. We're running at 20 volts, we're running in at 4.72 amps, and we're right in at 96 watts. Now our next test is going to prove that we're able to do 100 watts, which we already have that plugged in directly. You can see the meter here on the left-hand side is right in at 89. We've got another USB-C coming out of there, coming over to our converter plug, which is on our meter, and this is where we're going to be able to put a load on it. We're going to go ahead and start cranking the wattage up on the USB-C on the side here. Now you've got to look at something here. This is something that a lot of people don't notice, and I didn't know it at first either. Look at the voltage now that USB-C is putting out. Because it doesn't have the protocol going on, that handshake that I told you earlier, it went ahead and went to default, which is like 4.5 volts. So this one here is going to max out at about 3 amps. Right now we're pulling right at 3.5 amps, which is what that's rated at. We'll go ahead and take it a couple more watts up, and we'll go ahead until she trips out. Now it's going to most likely shut both of them off. So we got a max of 18 watts out of the one. So what happened there is the voltage actually dropped down far enough that the meter shut itself off, but we're still charging up here on the computer. You can see that we actually have the yellow dot, orange dot there. So just a quick screenshot for you, you can see that those are going to be either 3 amps at 5 volts, 9 volts, or 12 volts, or 15 volts, and then 5 amps at 20 volts. So it really depends on the handshake, what's going on there with the protocol. I'm not going to get into a deep discussion on how the USB system works, but that is basically why you won't see a higher wattage coming out of that port, because it didn't go to the higher voltage. Volts times amps is how you get your wattage. P over IE, basic Ohm's law here. Now this cable is an anchor cable, which usually is high quality stuff. I believe it was rated for 100 watts. We're going to go ahead and test out the USB-A plug here, so we'll go ahead and plug it into that one. So right now we're right at 5.1 volts. Starting off right now at 10 watts. We're at 4.8 volts, 11 watts, 12 watts, 13 watts, 14 watts, 15 watts. We're pulling right at 3.1 amps right now. So theoretically, we're already at the max of what it's supposed to do. But let's go ahead and push it a little further. 16 watts, boom, shuts down. So it's protecting itself. So if you have a phone that's not working right and it's pulling too many amps, the system is going to shut itself down. It went off on an EO11. EO11 is USB-A port overloaded or short circuits. They haven't nailed down to a T exactly which port is malfunctioning. Just hit your DC button down there, that reset the code. Now we've got the Anderson in here. I'm not able to put a 30 amp load on this. This can only go up to 180 watts. So right now we're at 12.15 volt. 0 watts. All right, at 175 watts, we're still at 12.18 volts. Current is at 14.3 amps. It is able to at least do half of what it's rated at. I don't have any 12 volt appliances that pull that kind of current, so we are able to do at least half the load test on that. Now we're gonna go ahead and test the battery backup section. Down here on bottom, we have the wattage coming in, we have the wattage going out, which is powering the laptop. Like I said, the laptop is being powered off the transformer. There's no batteries installed. You can see that the voltage coming out of the unit is 119 volts. So what we're gonna do is we're gonna go ahead and unplug from the wall. You're gonna watch that voltage change. It changed for a split second and it did not lose the screen. Now let's go ahead and do it again. See if we can confuse it. So I just heard it click. I'll unplug it again. Didn't lose the screen, plug it back in. There, it just clicked. Unplug it again. So it is switching back and forth, no problem. 20 milliseconds seems to be enough for most computers. You'll need to test that out with your device that you use before you actually need it. But as you see, the voltage right here is 120, perfectly steady off of the unit. If I plug it back in, you'll see that it is going to change to what the utility is, which may go up to 122. Yep, 122 volts. Now, just in case you're thinking I'm trying to trick you, to prove that it's actually plugged into the power supply, there goes the computer. So, it works. All right, so we're gonna go over the app real quick here. As you can see, I'm on the iPhone. We're looking at the Mega 2 right there in front of us. We're gonna click on that. It's connected right now on Bluetooth. This can do it on Wi-Fi and Bluetooth both. To do Wi-Fi, you'll have to add it to the network. So in the left-hand side, you can see the input is 0. If I plug it in right now, like you can see here, you should see it jump up. You can see the wattage starting to go up. Now on the output, obviously we have nothing. I just clicked on that. You can see the AC's on, now it's off. Click it again, turn it on. Down to the 12 volt DC right underneath the AC. See, I turned it off, I can turn it on. Just clicking on the circle button turns them on and turns them off. So you've got a readout here at the top. You've already chose. You can see what the temperature is of the battery. You can see what your level is. I'm gonna go ahead and unplug this. So up in the top right-hand corner, you see the little gear. You click on that. You can rename the unit, call it whatever you want. You can share the device. You can send that to somebody else. You got the temperature measurement. You can go Celsius or Fahrenheit. Here is the auto timeout. This is where you can shut the unit down if it's not being used. So never, all the way up to 24 hours. You get the screen timeout. You can have it shut off in seconds to never. You've got the AC timeout there, same deal. If you're using the power, it will not time out and shut off. But as soon as you quit using it, then it's gonna shut off. You have a firmware update there. You gotta make sure that you're connected to Wi-Fi. Asked questions and then specifications. This is gonna show you what the device has available to it. It's gonna have your watt hours, AC, blah, blah, blah. And there you go. For the most part, this app is very basic. It's the first app I think they've came out with, so it's got some work to be done on it, I believe, but it works. It's functional, but you know, there's some quirks to it here and there that I noticed, but for the most part, I don't use it very often, but it's there if you need it. All right, there you have it. This is the OPS Mega 2. So rundown of everything that it does and what it doesn't do. For the most part, I think it does pretty much everything that's rated for. The app, like I said, is a little glitchy. The door on the side here, you've got to be careful. If it's super cold out, that rubber can be brittle and you can break the bottom of it like I did. I'm sure if I got a hold of the factory, they would swap it out. Other than that, everything arrived like it should. The box was double boxed. It had very thick insulation in there to protect it from the ride over. The only thing I think negative-wise, like I said, would be potentially the noise from the fans, but once again, do you want it to overheat or do you want to deal with a little noise? Well guys, that's going to wrap the review up. I think as you've seen, the OPS Mega 2 here is a huge improvement over the previous models with the new features. The price point is the best out there right now. There is all kinds of sales going on right now in December, so if you're wanting to get one and you didn't get what you wanted for Christmas, right now, December 2023 is the time to act. So you want to get out there and get this thing bought now before the prices go back to normal. So if you guys have any questions, leave them down below. Make sure you check out my links. That helps support the channel. There is a discount code down there. Like I said, HVACR will get you an extra $50 area off. And till next time, guys, we'll catch you on the next one. Thanks for watching.